titled Through Advanced Computation. We'll focus on the third leg of computation that Jonathan introduced at the beginning. And we'll start with a presentation by Professor Bige Tuncer. Almost. Bige is a full professor and a chair of information system in the built environment at Eindhoven University of Technology. Her research focused on big data information design, urban analytics, and collaborative design process. Thank you very much for being here today, and the floor is yours.
Well, thank you so much for inviting me, Jonathan and Marco, and everyone else who had something to do with it. Very happy to be here. So today I am going to talk about what is the topic of this session, which is urban environmental intelligence through advanced computation, and then from the building to the city and back. First, a bit about my background. I am originally from Turkey, grew up in the south coast next to the sea, a bit similar to here. My undergraduate degree is from architecture. I'm an architect as a training. Then I also studied computer science, after which I moved to ETH. Well, my master is from Carnegie Mellon and my PhD is from Delft University in the Netherlands. After the master, I worked as a junior faculty at ETH Zurich. Then I moved to Delft. After the PhD, I was there as an assistant professor, after which I moved for 12 years to Singapore, where I more or less built my career. I was at Singapore University of Technology and Design, and I collaborated very intensely in the Future Cities Lab of ETH Zurich in Singapore as well. I had also visiting professorships at ETH Zurich, MIT, and University of Portugal during this period. Since last year, I moved to the Netherlands again. I am now at the Eindhoven University of Technology in the Built Environment Department, which is a combination of architecture, School of Architecture, and civil engineering. So it's a combination of these two disciplines. In Eindhoven, I am leading the information systems in the Built Environment Group, which is a multidisciplinary group of various engineers, some architects, some data scientists, and we are collaborating with social scientists in the university and also outside. We develop data-driven AI-supported methodologies for design and decision support tools and platforms for various stakeholders. So in my research, I always have a three-pronged approach. At the center is big, in parentheses, big data-informed, AI-powered design and planning support, where in the design and implementation of these systems, there is data which represents three parts. The first one is human and other living beings, their behavior, their mobility patterns, their perception, their appreciation of things, their opinion about different places. Then there is the physical environment with its configuration, points of interest, urban furniture, vegetation, and other physical attributes. And the third part is the sensible environment, which could be aspects of thermal comfort, air quality, noise, smell, and other sensible IoT-related elements. So within this context, we ask questions such as which behavioral hypotheses can be drawn from data sets and their combination? What is the relationship of these hypotheses with spatial and organizational aspects? And in order to do this, we collect, organize, analyze, and derive evidence from big and small, qualitative and quantitative, multi-source, multi-scale, multi-time data. We follow an interdisciplinary design process and a socio-technical approach in all of our research work. So I wanted to explain this very quickly through an exemplary project that we did a while ago. This was a project to understand usage patterns, users' assessments and opinions of public spaces in a dense residential area, and also look at as designed versus as utilized to understand how it is being used as opposed to how it was intended to be used. So this was a test bed site, which was a residential area in very close proximity to a very dense commercial area. We collected data at that time an experimental methodology, which I think is still a bit of an experimental methodology. This project started in 2015, so it was a while ago, but still it remains a bit of experimental methodology. We did an urban mapping of all the points of interest, which included also observations. This was recorded in a graph database with all these attributes. We installed some stationary sensors on the site, which recorded thermal comfort, light noise, pollution, etc. We developed an app which passively looked at the locations of the users, the residents, also had an active interface where they could tell, according to literature review, some categories of livability, how they appreciated these spaces. We had a partner who was doing workshops as well as a survey, a door-to-door survey of the residents. And we collected data from social media to do topic analysis and sentiment analysis, and in a cheeky way, developed a happiness index, place happiness index. Then we integrated all this data in a big data model and developed an information model from this, which organized the data according to places, time, slots, and people, a few selected demographic characteristics. And we could analyze this pool of data according to utilization, activity, opinion, and sensing. And we developed an online platform where the different stakeholders could analyze, deep dive into the pool of data to look at patterns that are emerging, also comparatively look at these side by side. We ourselves looked at this platform ourselves and extracted some principles for the planning agency who was the funding agency for this. And we asked our students in design studios to come up with some prototype designs as with the results that came out of this platform. And my colleagues built an actual physical space in the actual residential area as a prototype, and also evaluated its use through sensing technologies. So this, I show this very quickly to give you an idea about what I'm talking about when I say multi-source, multi-scale, multi-down data, and an integration of big and small qualitative and quantitative data. Because this exemplifies this really well. So we try to work on different scales of the built environment. We try to develop platforms, applications for designers and planners that span multiple design and planning scales in the built environment. And we do this through a lot of data sets. These data sets come from openly accessible platforms. They can come from many other sources. As you know, I don't need to go into detail of this here. But we use data fusion analytics, explanatory and predictive modeling, integrated systems. So we usually focus on not a single optimization, but focus more on what if scenarios, transition pathways, trade-off simulations, and we usually develop full chains post-test because there is no one tool that will solve all the problems for any kind of process. But if you understand, or if you map a workflow that can work for a problem space, then you can design and implement parts of a tool chain that can help designers and planners across their path of work. We use methods from complexity science, AI, We work with digital twins a lot. We work with various UI UX representations for different stakeholders. And we also focus on multi-stakeholder participation and co-creation within the process of developing these technologies and tools. The work overlaps a lot with the previous presentation this morning, which is nice. So AI, these applications and techniques, they assist in making the collection of data valuable for design and planning purposes. When there's a lot of data, AI helps designers and planners to interact with the data, make sense of a combination of data sets, and serves as a meaningful way of inclusive planning and decision-making beyond prescriptive conclusions. Planners, designers, planners can ask questions, they can do scenario planning and prediction, and a cooperation between the AI and human can definitely yield better informed outcomes than either the computer or the human alone. So I'm going to show you some student projects which kind of adhere to these points that I made. The first one is not my student, but I was in the committee of the student from NUS. This was a graduation project, master project. This student used generative AI and BIM-based to be able to generate 3D models through generative AI. Another student who is now currently ongoing, one of my graduation students, master student in Eindhoven, he is interested in participatory processes. So he is looking into designing, building a tool in Grasshopper where through, again, generative AI, participants can generate and play with scenarios in a real 3D setting for participation for a project that is supposed to be built. He is working with this municipality for this site with the developer as well as the landscape architect. This park is going to be redeveloped, and he's next week doing some participation tests on the site with the municipality using his Grasshopper tool, which at the moment looks like this, but he's working day and night to get it ready for this session next week. So he has a component, a library of components, which is organized in a knowledge graph, and using the OpenAI plugin in Grasshopper, he is able to, and he's going to add voice to this as well. The participants are able to place some elements in the park, and using natural language commands, move them and add new components, etc. In another project, a completed PhD project, which was finished in late 2013, one of my students was very interested in digital participation, and he was looking into the collected textual data through many municipalities and city administrations around the world. So a lot of cities have some sort of textual platforms where people will debate on things, write their opinions, then people will reply and vote and stuff. So he joined a conference where there were representatives of many of these municipalities, and he asked a question, he interviewed some of them. He asked them what they do with this data, and the response was, unfortunately, not much, because it is a huge amount of data which is collected, but how then to make sense of it and use it to help with the planning or design decisions is rather unknown. So he decided to focus his PhD on the topic of digital participation, asynchronous digital participation with textual data. So what happens is that he developed a new phase in participation, which we call post-participation, where after the participation campaign is done, the data is then prepared for action by designers and planners. So in order to do this, we used some techniques from AI, such as these, and developed a toolkit. He got a very large data sets from 3 municipalities in Europe and worked with them as stakeholders to implement some tools where you can make sense of the data. For example, the sentiment of the first layer of comments, how does that affect the depth of the conversation? What are the topics which are discussed? Can we actually extract location information from the comments in the data and to which projects do they relate to, etc. And we developed a web-based toolkit to help the designers to make sense of the information. And very luckily, he's now a postdoc with me in Eindhoven. I could get the funding to have him continue this line of work. In another finished PhD project, finished around the same time, another one of my PhD students, Katerina, was interested in the role of information technologies in design collaboration process within interdisciplinary AEC teams. And in one of her case studies, she got a very large data set, which is openly available, from the City of London. So the city is obliged to put all of the design documents and communication online for any building or urban scale project that the municipality approves. She got this giant data set. She applied a lot of AI techniques to it and generated a database from it where we can look at an individual's company affiliation, their amount of connections, which is derived from the correspondence, and also the number of communication events between individuals, and generated a graph structure from this. And then we can tie this to the time dimension, where we can try to see the influence of what I described before to the success of the project in quotation marks. In this case, success means, was it approved? How long did it take to get approved? Was it sent back for revisions? Was it rejected, etc. So after doing this case study, she defined the framework of the rest of her PhD about what she should focus on. Again, another student from NUS that I was on the committee, he was very interested in a rapid prediction model for urban scale facade solar radiation with graph neural networks. So this is related to Elam's current work, where the student was looking into kind of generative optimization of designing a new building as it relates to solar radiation in its relationship to the context, and how he did this. Of course, he compared this to other simulation programs, also the golden standard. And he represented buildings as all the buildings surrounding, as well as the building which is there, as vertices and edges. He derived the graph structure, and then he trained his graph neural network. The accuracy was not fantastic, but it can be improved. But the time is extremely drastically reduced with such a method. So there's a lot of future work in this direction. Another student, like many other students, are using specialized LLMs. So take a general LLM, then train it with a specialized data set, which is, in this case, a data set from online architectural platforms, such as DBIN and others, to make more targeted architectural concepts for students, to generate architectural concepts, which was really interesting work as well. One of my students in a first-year master course is looking into generatively optimizing the location of new amenities in the city center of Eindhoven. So Eindhoven is now referred to as the Silicon Valley of the Netherlands. It's one of now the richest cities because there's the high-tech industry is now in Eindhoven, and the city is growing hugely rapidly with kind of upscale expats and so on. So the municipality is going through the urban transformation process in the city center, where there will be 6,000 new, not residents, but 6,000 new residential units are going to be built there in the next few years. The plans are there. So she is still working on this, interested in looking at the walkability index, the walk score, and also generatively optimizing where new amenities should be placed in this new development. Another student of mine is also currently working on a graduation project to reduce neighborhood scale greenhouse gas emissions using a parametric process. So he is looking into building configuration, parameters under building configuration, parameters under energy use, and selected parameters under green infrastructure to model an area which is representative, and then defining different scenarios and simple optimization to give the stakeholders an idea about greenhouse emissions on a neighborhood scale. So we are using this multi-sector approach. I am showing you some current projects, but from now on, I will show you some projects which were finished or even not finished right before I left Singapore. But right now, the topics that we are interested in and working on in our new proposals, which I hope to report next time, are these kind of topics. I don't have a lot of time left, I'm moving on. The first larger research project that I want to talk about is one that was finished very recently, not published yet, part of it is published. So this was mainly a project with the Urban Redevelopment Authority of Singapore, which is the authority that approves all of the building projects, new development projects. So they were interested in using AI and other smart technologies to help them to semi-automate the approval process, but also to learn from it for future applications. And these are not only, so these are relating to codes, of course, urban and building related codes, but not only codes about simple things like setbacks, but more complicated things such as a commercial building, such as a shopping mall, must have a through passage, which must remain open for 24 hours and must connect the public spaces nearby. So how do you automate such a thing? So we focused also on this project on mobility, all kinds of mobility, pedestrian, active, as well as vehicular. So the idea was that there's a descriptive system that takes a BIM file, which is the submission is a BIM file. It extracts the features, it checks it against some planning regulations. Then we look at more the comfort level, also on the urban scale. We look at spatial and urban mobility and human environmental mobility in terms of thermal and acoustic comfort. And we do a decision and control layer, which has the AI side, which I have to say did not work very well, so I will not be reporting on that part. But yeah, it's good in the future, I hope. So we extracted the data from the BIM model, represented the building as a graph in different layers. Then we collected all of the relevant codes from all the different agencies. We checked some of them against the graph that we have. We also developed a Revit plugin for both the planning agency, but also architectural consultants to be able to do this before they submit their design. Then we represented this as a graph and for interoperability between the different analyses. Then we developed a chain of activities of probability for an agent-based simulation to look at crowding, wayfinding, etc., in the generally accessible areas of the buildings. And in this workflow, we use the data from John Min's project, City Knowledge Graph, to probabilistically distribute the functions of the different stores in the shopping malls, as well as the land use in the 800-meter radius area. So after we developed this probabilistic model, then we ran our agent-based models And we came up with a foot, let's say, crowding pattern in the general areas. And then we developed a simplified and faster way of doing this by generating an adjusted network centrality analysis, which then we checked the accuracy as opposed to the agent-based model. It is good enough, and it takes a very much fraction of the time to run such a simulation. So this was already a good input for the planning agency to check this. And then we took the ground floor network and plugged it into wrote a script to plug it into the urban scale network to check the accessibility in the urban area before and after this building is built, and how it changes the accessibility, the mobility in the urban area. My colleagues of the acoustic part also did their work to see if the functions here are posing a lot of problem for the immediate neighborhood. And the idea was to build a graph neural network as a surrogate model, which could do the same for the other types of analyses. This was, by the time that the project had to be completed, not very successfully implemented. But as a thought process and as a method, I think it holds still a huge amount of potential for the future. And the last part that I want to show, I think there's a relationship with Naga's work and also a future collaboration possibility. So I had a PhD student who was interested in the thermal comfort under the covered walkways in Singapore, because in Singapore there are, I mean, you probably know the climate, it's very hot, very humid, it rains a lot. There are a lot of covered walkways, like, I don't know, thousands of kilometers. But it turns out that the agency who designs and implements these never really did a study about thermal comfort and how to design these to improve thermal comfort. So my student did his PhD on this, and he developed a methodology, and we built this tool where you can click anywhere, and it will generate a segment of a covered walkway, run the simulation under and next to the walkway, and it's going to tell you in the hot afternoon hours how well this works, based on, of course, a certain material selection. So he developed this methodology. Then we presented this at the workshop of the Cooling Singapore project at XDR. The director of the National Parks government agency was there. He saw the poster and he said, oh, a call is coming up, you should apply. We applied and we got the grant. So we got to extend this with a project of cooler green spaces. So here, the idea is to identify and develop strategies and interventions to improve thermal comfort in outdoor park spaces through passive design of tree planting. So how do you improve outdoor thermal comfort by planting trees in a good way, and which trees, which kind of design configuration, etc. So we started looking into literature review of passive outdoor cooling to collect some best practices, etc. We also looked at perceptions of thermal comfort. What should we take into account when designing such systems? Then we wanted to develop a thermal comfort baseline. So we devised a methodology to select certain locations in existing parks to measure the existing situation. So in order to do this, we made our model, parametric model, where we took into account the park parameters, the number of trees in different parts of the park, the number of buildings around the perimeter, etc. And we also got the data of the local climate zones in Singapore and juxtaposed this to the park outlines. And then we made a selection of the measurement locations where we should measure to be representative of various urban situations in parks. So we did the measurement in a 20-meter radius. We took into account all the trees. We measured all the tree characteristics. Then in a 30-meter radius, we recorded all of the surface temperatures and materials. And in a 50-meter radius, we recorded all the building facades that have an effect, radiation effect on the thermal comfort. And we recorded all of these. And then we plotted the values. And we had files like this. We had a database of the tree species, the LAI, everything. Then we also conducted some control field experiments in a real world environment as much as possible, understand the effect of tree distance and the various tree characteristics to thermal comfort. So there was this area owned by Ann Parks next to the tree nursery of this agency. So we were able to get baby trees. I call them baby trees, but they are saplings, little trees, which represent, of course, not the same species, but the tree characteristics represent, let's say, full-grown trees. So we put them in different distances in a scaled way. And we did these measurements for about 10 days. And in another experiment, we did this with different tree species, which have different shapes and different leaf area indexes, etc. And we collected this data and we came up with some conclusions about that. Then we decided to test how to set up the model for simulations in the Singapore environment. So we did a sensitivity analysis and came up with what the model setup parameters should be. And then we started doing our simulations for data generation. First, we did tree simulations, distance, leaf area index, etc. And we also had some workshops with the designers and park managers of this agency to come up with how we should design our large-scale simulations. So we decided to put a pathway, which is now a big problem in Singapore parks because they are used in the morning and evening, but in the afternoon, they are also used a lot by commuters. So how do we, let's say, make a path between largely used points of interest, which are on the perimeter? So we made our simulation models accordingly. We made the finish. Okay. So we made these simulation models. We generated a lot of data, and then we did not do machine learning. Hence, we have this data. We did a lot of statistical analysis and came up with some rules of thumb, which then we translated into design recommendations for the park managers and designers. And we did a workshop with them to tell them this knowledge. It was very nice. This is not yet published. Did not find it. So we are now, as we all know, in the history of design computation here. Everyone is trying to work on this. This is the state of the art. These techniques and methods can be applied everywhere in the life cycle of a project. But of course, everyone talks about that AI is going to have us lose jobs. A friend of mine in Singapore mapped this to our discipline, AEC discipline, this famous chart. And we see that the safe zone is human plus AI. So Jonathan's point of where does the human need to come in? What can AI help us with? What can't AI help us with? AI is missing learning abstract concepts, data-efficient learning, social learning, one-trial learning, systemicity of the language of thought, and meaningful composition. In context, situated. I don't know why this looks like this. But automation versus augmentation, we are all for augmentation. A joint working of human and AI is more meaningful in our discipline, for sure. AI application exceeds the human capability in some ways, but it is inferior to human capacity and capability. So I think that we as builders of these methods, we the researchers in our specific field must be very aware of this when we design, but also explain what we are doing. And also, another concern is always transparency, black box versus control of process for architects, designers. We must be very mindful of this. And we must not focus on, of course, we must focus on productivity, but not only on productivity. We must also focus on learning and design exploration explicitly. So this is the end. Thank you so much.
Thank you very much, Bige, for the insightful, wonderful presentation. Well, it was right on time. A bit intimidating as a student, as your student to see. A lot expected. I think we can open now the floor for questions from the audience.
So thank you again. It was an amazing presentation. And I'm wondering, like, I know it's not fair to choose among the kids, but from all the very vast, you showed us like vast different options to use AI with. Which one do you think is the most promising?
I think that for us, if we are looking in the discipline of architecture or urban design, in these disciplines, I think the combination of qualitative and quantitative seems to be very, very promising. Because the problems that we talk about, that Jonathan opened the day with, these require a very multi-viewpoint approach. So this human-centered or living being-centered, if we are thinking of biodiversity, this approach needs to include different, it must include a lot of hybrid sources of data. So this heterogeneous data, I think, is the very interesting future. But other than that, if we come to a more technical part, for me, the use of surrogate models or related concepts, which reduce simulation time, is very, very crucial as well. Especially in early design, when these decisions matter the most, or to get the most meaningful insights. This is, I think, very crucial. So these two for me are very, very important.
Thank you.
Anyone else?
Okay, if there are no further questions, I'm wondering, because we are in the age of expertise in academia, so we have different chairs. We have a chair for computational design, then we have a chair for environmental design, and then we have maybe a chair for design. And when I'm looking at the project, and I'm wondering, do you think it's appropriate to have this distinction between computational academics and researchers and then environmental academics? So maybe both of them can come as one and we should somehow merge our expertise, because I see a lot of proficiency needs to be there when the decisions that your students in the chair of computational design had to acquire in order to make the decisions of data gathering, of the metrics, of the analysis, of the computational complexity that you need to have when you come to measure thermal comfort, right? So this is just an open or maybe a provocative question, because maybe in the end of the day, we don't need environment like chairs like mine, because all architects have to have it, right? And maybe also computation, something like that. So where do you think it is going?
I believe in disciplinary knowledge. Domain knowledge is important. So I will not comment if this chair is needed or if that chair is needed. I think your chair is needed and my chair is also needed. But the student, the PhD student who developed the methodology for the NPARS project was an environmental engineer. We worked with Thomas Auer. So I don't know anything about physics. I didn't know anything. I wrote that proposal with colleagues from FCL who were experts on ecosystem services and thermal comfort. So we wrote this proposal together. Then, because of many reasons, practical reasons, they had to drop out. And I had the possibility of giving up the grant or doing the grant on my own. It was COVID. I could not find a postdoc. I spent day and night on this project, learning myself like a student and doing this project. And it was very difficult for me. But I learned it. Now I want to go for it. I think that multidisciplinary working, so without that domain knowledge that PhD student came, did his PhD with me, he had also a co-advisor from the computer science department who was an expert on AI with small amounts of data. So without this combination, this could have never happened. I think that domain knowledge is extremely important. But we need like an orchestra chef. So I think that I am good at this. This is one of my strengths. I can speak the language of engineers. I can speak the language of designers. I can speak the language of software designers and people who implement it. So when there are enough people around like this, and there are enough people around like this, I think that these processes can work much better. But I think that the depth of knowledge, the scientific disciplines is absolutely necessary. I mean, people who design, who are urban designers, are also extremely necessary.
Okay, so I can ask the question. Great. I think going to your last project that you showed, or actually a few of them, in Singapore, it's very interesting, the combination between practice and academia. And I think it's not very common. I think we talked about it a lot, but maybe you have some comment about that.
It is less here for sure. Here means in Europe, I don't know Israel. In Europe, it is less than in Singapore. That's my observation.
Even less.
It's my observation. I've been here a bit more than a year now, slightly more. I work with municipalities already in Eindhoven, but also now we have a project about data spaces on European level, where there are 2 other municipalities involved. The collaboration, I think the building up of trust, or I don't know what it is, but building up of this collaboration takes time. Maybe, I don't know, in Singapore, the universities are very much integrated into the landscape of the knowledge industry, knowledge economy, etc. And in Europe, it seems to be slightly less. But I think the opportunities are there. You just have to, it takes time. You have to work on it. In Singapore, my lab's collaboration with the government agencies was very strong. Really very, very strong. But the collaboration with companies was also there, but less strong. For example, I can give you an example. There's this government agency called Bige, Building Construction Authority. They were having an event. I did a very small lecture there. After that event, one of the practicing architects who was in the audience, who I knew very well, came to me and said, "Oh no, you shouldn't have shown this now. They're going to ask us to include all of these things in our submissions." There's a fear. There's a big fear because architects don't get paid well. They don't get paid well. So this comes back to the business model comment of Jakob. So the business model, I think, is a very crucial aspect in it. So if they could get paid for including all the new things that they have to do, carbon, human perception, this, that, then I think the industry collaboration could go much better.
Okay, so I can continue the conversation. Maybe final note, continue what you said. I think maybe the data accessibility in Singapore and Asia is a big factor.
You can find data everywhere. I look at this as a, you cannot find some data. For example, the electricity data was mentioned this morning. In Holland, also this is an issue for specifically for that data set, but there is aggregated data. So I look at these processes and we always use a form of the design thinking or design science methodology when we design our research. So when you do this, it is integrated, the user-centric approach is integrated in the method itself. So when you frame or reframe your problem, then you have to look at what kind of data is needed to have an effect on the solution of this problem. Then you need to look at what data you can realistically have, who you need to partner with, and then these two have to massage each other, and this is the way you have to realistically partner. But there is data.
A good note to end with. I think round of applause